The mold features a multi-cavity design with the Student Aerospace Initiative logo that allows for 2 keychains to be fabricated per shot. We were originally planning on doing the Georgia G logo, but we thought this would be more creative and would allow us to promote a student organization in the College of Engineering. The design was extruded into the surface of the mold and a hole was added to allow for the piece to be placed on a keychain. The mold also features a fill gate to prevent jetting and allow for a smaller refined gate to increase the stress strain, making the plastic more malleable. The mold was designed in Fusion 360 using step files provided by the APSX website. The mold has a tolerancing of about 0.005 inches for ensured fit. The mold consists of 2 separate pieces that are placed in aluminum blanks which fit directly into the injection molding machine. The molds have 4 holes at each corner that are countersunk to allow screws to be placed flush with the mold surface. To ensure that there is no interference between the screws on the 2 separate mold pieces, only 2 screws will be placed on opposite corners on each mold. This prevents any potential damage to the machine or the user.
The test molds were initially created by 3D printing the design on some of the FDM printers in Driftmeyer. A Dremel 3D printer was used to fabricate a test sample that we could fit into the aluminum blanks to ensure that the tolerances and fit of the molds are correct before printing on the SLA printers. Here, Reames is fitting the test mold in the aluminum planks to ensure that our dimensions are correct before we print on the resin printer.
SLA resin printing is used for printing the final version of the mold. The Formlabs 3 SLA printer features the ability to print with a high temperature resistant plastic material that can withstand the temperatures experienced during the injection molding process. The parts were oriented at a 20 to 40 degree angle to reduce cross-sectional area during the print, which reduces the force on the print bed and decreases the chances of failure. The print was done at a 0.05 millimeter layer height to ensure precise and accurate tolerances. This gives the part approximately 2,233 layers, which took around 34 hours to print.
Here, Reames is removing the print from the resin printer sheet. He is careful not to touch the part and only use a chisel to put the print into the isopropyl alcohol washing tank.
Starting the bubbles up. Yeah, there we go.
In order to cure the resin mold after the resin printer is done with the process, we soak the mold in isopropyl alcohol for about 6 minutes at a temperature of 120 degrees. When the process is done in the alcohol, we put it in the dryer for 2 hours at a temperature of 80 degrees Celsius. Here we have Luis and Logan cutting off the supports of the resin mold. After they are done cutting off the supports, Jack has to sand down the mold in order for all of the support structure to be completely gone so that the mold fits perfectly in the aluminum blanks of the injection molding machine.
Here we have a thin sheet of silicone that we will place in between the mold and the aluminum plank in order to prevent the mold from cracking.
So this is your basic injection molding machine. Essentially what you have in here, you come over here. There you have 2 blanks. This is a blank without it being machined out. The ones we have are machined out to fit dies such as this. We have our die made out of high temp resin sitting in there right now, and a piece of silicone sitting behind it to protect it from too much clamping force. So the way this basically works, you have your control box here, or the brains of it basically, and then we have a tablet up here to run it. Essentially back here, this is where you're going to be applying a clamping injection pressure. It's going to be pushing a rod in to actually push the plastic through, while this servo motor drives the clamping force so the 2 actually sandwich together and keep held so the plastic doesn't actually seep out of the edges. And then we have our hopper servo. Basically it allows it forces more plastic down into the tube to be injected. And then lastly, we have one other servo right here, which is basically the nozzle inlet. Basically, it'll open up and allow to keep constant pressure on the injection while maintaining a certain fill speed. Lastly, we have a cooling fan up here to maintain constant pressure, as well as other thermo elements right here that heat up, and then fins to actually cool down the hopper itself so we don't melt any of the plastic up here. Aside from that, you have linear bearings along all of these rails, and it's just a square tube frame. But yeah.
Finally, after the injection process is complete, we carefully remove the final product from the injection molding machine. Because of our mold design, we come out with 2 plastic SAI keychains.
So we ran into a few different issues that we could learn from for our next experience with this. One being the supports being printed on the wrong side of the mold and actually being on a mold face and giving some texture to the back side of our finished product, as well as when troubleshooting the machine, using our troubleshooting guide online to actually adjust different settings. And lastly, what we can do to improve in the future is actually add some depth behind the sprue so that it ejects it with the mold instead of leaving this plug stuck in the machine and failing the second shot. One of the other things that we learned that we can do better next time is actually offset the screws so that we don't chip molds in the future, as the screws actually protrude into the other side of the mold.